In question 7, the 15 arm of a crane is horizontal before it lifts its load from the ground to a point 9.4 meters vertically above the ground. What is the angular elevation through which the load has been lifted? So here's the crane. It was normally in this direction, but it turned to this direction. This is a 15-meter long crane. It has raised high vertically so that it will be 9.4 meters high above where it normally is. So we're going to find out theta. Okay, so I've redrawn that triangle out, and what we're going to use is the sine ratio, because this represents relates opposite and hypotenuse side. So we're going to use sine of theta equal to 9.4 over 15, and then inverse sine both sides of that, so that theta is inverse sine of 9.4 over 15. Okay, and then what that gets you, let me just check the calculator, is theta being 38 degrees. Okay, 48 minutes to the nearest minute. Right, let's move on to question 8. Joy is sitting in a treetop 3.5 meters tall, and she observes Fritz the cat on the ground 2 meters from the base of the tree. Calculate the angle of depression from Joy to Fritz. So here is Joy. Joy is on a treetop that is 3.5 meters tall, observes the cat down here, and you want to find the angle of depression. So the angle of depression is measured from the horizontal at a downwards angle, and this angle here is alternate to this angle here. So that means they're equal. So just by using this triangle now, we now can relate the opposite edge with the adjacent edge. So using SOHCAHTOA, this represents the TOA bit. So tan theta equals to opposite of adjacent, which is 3.5 over 2. So theta is the inverse tan of 3.5 over 2. That would be theta is approximately 60 degrees and 15 minutes. Let's have a look at question 9. A sailor sights a fortress on top of a 45-meter cliff from his position 1.6 kilometers out from the base of the cliff. What is the angle of elevation from the sailor to the fortress? So here's the sailor. This person looks upwards at this particular cliff here, and there's a fortress here, okay, on top. All right, so here's the fortress. And it's asking what is the angle of elevation when the cliff is 45 meters high and he is 1.6 kilometers away from the base of the cliff. Now what you got to actually observe is this is different units. So this needs to change to another unit, which is meters. So if I times that by 1,000, this would equal to 1,600 meters instead. So we're now going to use that number, as well as the opposite edge and the adjacent edge. So using SOHCAHTOA, we know that we're going to use TOA, okay, which means tan of theta equals 45 over 1600. We get theta equal to inverse tan of 45 over 1600. Okay. And so theta would be approximately 1 degree and 37 minutes. All right, let's go on to question 10. The angle elevation from D to B is 30 degrees. Okay, so from D to B, this angle is 30 degrees. And the angle elevation from D to C, so from D to C, this elevation, is going to be 45 degrees. Okay, AD is 20 meters, which is down here. We want to find the distance of B to C, so this edge here. Okay, now BC, this edge here, is the same thing as CA minus BA. We're going to try and find those two. So if I redraw the big triangle, I've got D, A, C here, and here's a smaller triangle, which has D, A, B here. So I've got 20 here, 20 meters here. This is now going to be 45 degrees, and this is 30 degrees. So let's try and find out CA, first of all, which is this edge. That would be the opposite side to 45 degrees, as well as adjacent. So that would be using tan ratio to find out that side. So tan of 45 degrees is the opposite edge, which is CA over our adjacent edge of 20. We're going to multiply both sides by 20 here, like that, so that this 20 cancels out. So CA is simply 20 tan 45. I'm going to leave it as it is. Then we move on to this triangle. Opposite 30 degrees is BA. That's what we're trying to find here. So that's opposite, whereas this is adjacent. So we're going to use tan ratio again. So tan of 30 is BA over 20. We're going to once again times both sides by 20 so that these 20s cancel. So BA is then 20 tan 30. Now, if you want to find CB, we've got to write the statement. CB is CA, which is this whole thing, okay, this whole edge, but we don't want this bit, okay? So we get this length minus this length, and that will give you this length. So that way, it's basically CA, which is the whole entire thing, whole entire edge, minus BA, the smaller edge. So we've got those two quantities here. So CA is 20 tan 45, and BA is 20 tan 30. So I'm going to write that in. So if I type that on my calculator now, I do get 8.452, which is approximately 8.5 meters. Okay.